So this is just a short 10-minute demonstration of SmartValve and some of the key features that are included within the app. So as we've already discussed, SmartValve is there to do one primary purpose, and that is really to change the behaviours of the technicians who are out in the field, turning the valves on a regular basis. So our app is trying to drive those changing behaviours. It's trying to ensure that they turn the valves in a way that decreases or eliminates the likelihood of transient pressure water hammer being introduced into the network. And that's really important for a number of reasons, as we've probably already mentioned. So leaks, bursts, water discoloration, they are the key drivers. So transient pressure, water hammer is a known cause of all of these three things. And if we can reduce the amount of transient pressure in the network, then we'll be able to reduce the amount of leakage through leaks and bursts and the amount of customer complaints through water quality incidents. There are hundreds of other benefits in terms of the data that we're collecting here out in the field and how that forms part of a truly smart water network, including a live hydraulic model. But just for the purposes of this demonstration, I'm just going to show you the quick and easy way that an operative out in the field can set up an operation, how SmartValve guides them through that, ensuring they return the best practice on the valve turn, and then just look quite quickly at how we can also improve the data for all of the assets that we've got here in SmartValve as well. So we're looking at the home screen now. So I've logged in, I'm seeing the jobs that I have. I've got two jobs, one on this valve and one on this hydrant over here, and I can scroll between the two. But I'm just going to click into this valve here. So I'm going to have a look at this one ending in 705, click on the blue square, and that opens up the detail for this valve. So it gives me some immediate information, tells you the valve is currently open, tells you the unique valve ID and the size and type of valve and its location in terms of the distance away from me. And then here on the map behind, we can see its location on what is called a DMA, so a district metered area. So in the UK, we cut up the water network into chunks. So our local authority has about 2,000 DMAs. And SmartValve gives the technicians the ability to visualize these DMAs. So here you can see the boundary in the square, we can see the blue mains there, and we can see the valve sat on top of it. So the green indicates it's open and the icon indicates to the user it's a sluice valve. But if we click on that map, then we get into a map that we can interact with, and we can see all the valves and we can see all of the DMAs. So that's scrolling out on the map. And then by scrolling across these valves at the top, we can see all the different valves that sit within it. We're going to go in and have a look at this one where we are. So that blue dot there indicates my location. So the technicians can walk around the patch, get to a particular valve. When they find the one that they want to have a look at, they can simply click on the valve and they can have a look at the valve detail. You know, if they're away from the valve, they can get directions to it, or they could add it to their plan as well, really simply. But I'm going to look at this valve here, and we'll go back and have a look at the valve details. This is the one that we're looking at before. I'm going to quickly add an operation in here. So if I scroll up on the screen, there are two different types of operation. So there's a single valve operation for the technician, so that's the blue one there. And then we have the grouped tasks. So you can set up group tasks within the app as well, or they can both be done, both the single and the group ones, through the web application and sent to the users. Now those jobs can also be fed from third-party services such as SAP or any works management, Maximo, whatever you might be using. And all the data can also be integrated through our APIs with GIS, and the data pushed and pulled back from and to the organisation in real time. That's where the real value of SmartValve then comes in terms of the core strategic planning of the water company, in knowing the life status of all your valve assets out in the field. But I'm going to quickly add a new operation on here. The valve is currently open, so I'm going to either turn to close. So we can see that then comes up. And if I click on that now, it's going to talk me through the process of doing that turn to close effectively. So in the UK, they train the technicians on transient rigs. These are overground water networks with pressure sensors and loggers and screens. And they devise the best way to turn valves based on their topology, their geographic location, the way they run the hydraulic model, the pressures that they run the network at, and say, right, in real terms, if we turn a valve in this way across the board, it shouldn't introduce pressure, unwanted pressure, into the network. And that tends to be a percentage. So our local water company is 80-20. So if you have a 10-turn valve, 8 of the turns will be at one speed, and 2 of those turns will be at a much different speed, and usually the slower speed. So it's those 2 turns which is the critical part of the turn. So if you're opening a valve, the first 2 turns will be really slow. If you're closing a valve, the last 2 turns will be really slow. So we can embed all that best practice into SmartValve's dynamic turn profiles, so they're all embedded into this system. This also means that with the loss of skilled workforce, with them retiring, especially here in the UK and in the States as well, which we know, you have a lot of the older generation leaving the service, retiring, and we have younger technicians coming in with less experience, we can bake all of that experience into our app, so we're not losing any of that. And we're guiding the younger workforce on how to do their job. And of course, they're much more used to be guided in using an application such as SmartValve out in the field. So we see the take up for the younger generation is really quick and really easy. It's very intuitive. So they will see, the way that they're being shown to turn the valve isn't, teaching them to suck eggs, as we would say. It's actually providing them with really good information and data to ensure they're protected and supported in doing their job. So now we're going through the process. We have a simple way of attaching our smartphone device, which runs the SmartValve app, onto a valve key, either the shaft or the handle, through a quad lock system. So it's make sure your position's ready to go. We're then placing the key on the valve ready to turn, and it gives you some information about this valve. So it's 73 millimeters and the orientation to close is anti-clockwise. We can change this, so if we wanted to edit the size, we can do it. If we wanted to edit the units, we can do it. If we wanted to change the orientation, we can do that as well. But this is correct, so we'll leave it as it is. We confirm the initial status is open, which it is, but we could change this again if we wanted to. So if we got there and we found the valve was closed and we got an open operation, then, that's okay. But if we've got an open operation and it should be closed and we're about to open it, then we'd have to go in, change the status of the valve, delete the job and start again. And that happens from time to time. But obviously, as the rollout of SmartValve becomes across the business, then these are dynamically created. So the statuses are based on the last known operation. So as long as everyone's using it, the valve should always be in the correct state. So we're going to confirm this now. So now we're going to say, yeah, are you ready to go? So we press calibrate. This is now setting up all the sensors that we use in the phone to detect the rate of turn, the speed of the turn and the direction of turn, and obviously the number of turns. And this will say whether it's in horizontal or vertical mode now. So now we've got this first, because we're closing the valve, these first steps will be really quick, or can be really quick. So although because I've got the microphone on here recording my voice, you won't be able to hear this as loud. And it's one of the quirks of recording your screen in iOS. But it will say, step 1 of 2, 5.6 turns anti-clockwise, no more than 30 revolutions per minute. So it's taking me down, 3, 2, 1, and I start. So if I start turning the valve,
you seem to be turning this valve in the wrong direction.
You can just hear in the background there saying it's turning it in the wrong direction. So yeah, I need to go anti-clockwise, so it's warning me. And I can start making these turns. And for this part of the turn, because it's 30 revolutions per minute, you'd expect a technician to just be turning this valve nice and smoothly.
You seem to be turning this valve too fast. The standard turn profile for this valve allows a speed of 30 revolutions per minute.
But what it's doing, it's giving me that guidance all the way through. So as I get through to the 5.6 turns of this first step, it will now drop off and say we're going on to step 2.
Warning, you seem to be turning this valve too fast.
And now
the standard turn profile for this valve allows a speed of 5 revolutions per minute.
In the real life instances. But it's now telling me the valve turn profile's changed now, so I can only go 5 RPM for this last 1.4 turns. So if I break it again, it's going to flash red and it's going to tell me I'm breaking the speed. So we're always monitoring those behaviours. Now we get around to the required turns, which is 7 turns. Now, if we haven't checked the valve and it's not a 3-inch valve or a 75mm valve or whatever we set it as, and we still need to close it more, then we can carry on turning, and SmartValve will carry on recording the turns and informing you need to do it at a particular pace as well. But let's assume we've closed this valve, we press finished, we've now completed it, we go on to our next step, and we're given the appropriate, so say, well, was this turn accurate? I'm going to say yes it was, or no it wasn't, but yes, in this case it was. Go through to next, confirm the valve status is closed, we confirm, and we finish the operation. So now that's gone, I've done that, turn to close, we can see that the closed is now indicated by the red at the top. You saw the background sync take place, and now that's pushed that data back through the cloud and will be picked up by our web application through the API. We'll be able to see the basis of that turn. And here my valve history at the top now, you can see the turn to close, which we've just completed in there as well. So really quick and really simple to do those operations, but it's all about guiding and having those principles in there to say, yes, this is how we turn a valve, and if we follow these instructions, we're going to reduce or eliminate that likelihood of a transient pressure water hammer being introduced into the network. So very, very briefly, we just looked at being able to edit the valve details, so we can go in and edit everything that's been imported from our GIS system. Obviously, if we have a live link to GIS, and anything we update here can go straight into the GIS system. So this gives the users the opportunity to improve the asset data that's in the GIS system. UK GIS system is patchy at best. This went on trial at Severn Trent Water before they purchased it earlier this year. And they've changed 9,000 pieces of data within a 6-week period from their GIS system because it just wasn't right. You know, valve sizes, orientations to closed, types of valves, locations, etc. So we can set the location here, so we can drag and drop the valve at different parts of the main should we want to. Obviously, that's only going to be good for about 2 meters using the GPS on the smartphone device, but we do have an integration with a Trimble catalyst. So Trimble produce really good high quality GPS location devices, and that will locate the valve or the asset, the pipe for example, to 1 to 2 centimeters. So we can get that level of accuracy by using the Trimble devices, which seamlessly integrates with SmartValve. So for developing countries or for areas where the GIS system isn't as good, or perhaps they haven't got a GIS system, this and our database can collect all of that valuable location data, so we can pinpoint exactly where our assets are as well. So all that's available in there. We can take images as well, so we can take images, add them, we can annotate those images on screen as well of the particular valves. So that's just a very quick walk around some of those core functions. I just wanted to show you the key to this, which is about those changing of behaviours and ensuring that we can get those valve turn profiles dialed down to an appropriate level. You know, and we'll talk a little bit more obviously in our presentation about some of these wider aspects about the data and how that integrates into the business and the value that brings as well.